So let's look at calculus. In this particular case, cubic equation, we actually going to consider first and second derivative. So here we have function f and g, two different functions, and they are defined as follows. Don't forget that what you have always on top of the fraction can be written beside the fraction. So that looks more like we can recognize cubic function and what quadratic one. The graphs of f and g are used to make an image of a wave for a logo. The wave is region bounded by. So what does that mean that it is bounded by? It means that for function f, the cubic one, the value of x is between 0 and 2. And we can see that on the graph. That's my 0, that's my 2, and that's my f function. And that's where it is within those two limits. Now, when it comes to function g, the value of x, now here is different between 1.5 and 2. So here, that's my 1.5 and 2, and that is just the part of that function because it's a quadratic, so obviously it will keep on going. That cubic as well will keep on going, so we know, but we are just looking at small because that one will go here at just a small part of the graph. The vertex of the wave are labeled A, B, and C, so A, B, and C. So the first thing we have to do here, let's remove that, drawing here. We have to verify that g, so this function, cuts the x-axis at the point x equal 1.5. So what will happen when we put in place x 1.5? That place here, isn't it? That's 1.5. So the coordinates here, let's just remove that. Coordinates of that point will be what? 1.5 and 0. So that means we should get 0 as a value of the function. So if we take our g function here and we replace x with 1.5 to the power of 2 plus 25 multiplied by 1.5 minus 24, we are saying it should equal 0. And when we put all of that in our calculator, indeed we get 0. So indeed it is verified. That's where it cuts the graph. Okay, let's have a look at next part. So next part is saying use calculus to find the maximum point. And they are very kind to point that out because once we know when we are talking about the maximum or the minimum point is the derivative that is going to help us to find. So how do we do that? First thing is to create derivative of a given function to us. Second thing, we take that derivative and we equal it to 0. The third, we take we solve it for x, Then the next part is that we take that x back to the original function to find the corresponding value of y. So that's what we do. So our fx function, let's write it. And like I'm saying, it is easier when we put that x to the power of 3 beside 1 over 4. So how do we derive it? Each element separate, isn't it? What's our formula here? That's, where is the, there it is. That's the very first one. I have x to the power of n goes in front, and then power minus 1. So in our case here, to create that derivative, what happens with that minus 1.4? Whatever coefficient stand in front of x, we are creating derivative, it goes over. Multiply that power goes in front, and then the power minus 1, and the same thing happens with the second one. Power goes in the front, and then my power minus 1. Oh, my apologies, that should read 3, not 2. And then, so we are saying, okay, let's deal with the numbers. So minus 3 over 4x to the power of 2 plus 2x is our derivative. We equal that derivative to 0, and then we solve it for x. Now, it is a quadratic function. We could use minus b formula. Now, if you are wondering, the only difference here is that we don't have c, so c will be 0, and we can put that in our minus b, or we can take x in front of the bracket. That will as well work, and therefore we have just two factors. So, let's just move that. That's the next part. So that means one is x equals 0. The second one minus 3 over 4x plus 2 equals 0. Then we move our 2 to the other side, therefore change the sign. And we want x, not x multiplied by a number, so we divide both sides by minus 3 over 4, number that stands beside x. And when we put that in our calculator, we get that the value of x here is 8 over 3. Now, that is the maximum value of x. How do we know that? It's because when we are looking at the graph, we can see that that is when x is 0, isn't it? So that's not the place we are looking for. That is the place we are looking for. So our value of x we are looking for, that's 8 over 3. Now, that's not finished because we have to give the coordinates of that maximum point. So now that we have the value of x, what do we do with that? We take it back to the original function, and we are saying, let's find the value of y when x is 8 over 3. So minus 1 over 4 multiply instead of x 8 over 3 to the power of 3 plus, and again instead of x 8 over 3 to the power of 2, and we put that in the calculator and we press equal, and we get is 64 over 27. So that is our maximum point, 8 over 3 value of x, and 64 over 27, that's the value of y. Okay, let's have a look at next part of this question. So here they are saying use calculus to find the x-coordinates of the what? Steepest part of the graph. So how do I understand? The steepest means what? If I am looking at the graph, I am looking at what point the graph goes up the most, isn't it? So we are referring to what how I say, what feature of the function? We are talking about the slope, isn't it? So we are saying, so the slope. So how does the slope connects to the steepness of a line? It connects the bigger the number of the slope, the steeper the slope. So this is a bit of knowledge that knowledge that we need. So basically, if the slope, the bigger the number of the slope, the steeper the line is. Okay, so that means I am looking for the maximum value of the slope, isn't it? And how does that slope connect with calculus? Because value of the slope is the same as a value of the derivative. So I am actually looking, if I'm looking for the maximum value of the slope, I am looking for the maximum value of the derivative. That's what I'm looking for. And we've done our derivative in previous part. That was my minus 3 over 4 x to the power of 2 plus 2x. Isn't it? Let me just check if I copy. Yes, it is indeed. So that's our derivative. So if I'm looking for the maximum value of the derivative, that means what? I'm looking for the maximum place. So I create a derivative of that. So how do I do it? Each element separate, the same idea we are applying when our function, our element is x to the power of n, we take n in front and then power minus 1. So our second derivative in this case will be what? Minus 3 over 4 crosses over, multiply that, 2 goes in front, multiply by x. Now this time 2 minus 1, that will be 1 plus, and here when there is no power beside x or power of 1, the derivative is the number that stand beside x, so that will be 2. So the process is the same as with the main derivative. We equal that to 0. Minus 3 over 4 multiplied by 2x plus 2, and then we solve it for x. So we take 2 to this side of the equation, we change the sign, whatever these values are, I can find it or not. And then what do? We divide both sides by the number that stand beside x, isn't it? And we divide both sides of the equation. So that goes, I have x left, I put that in my calculator, and when I press equal, we get that this is 4 over 3. So at the value of x, 4 over 3, my f(x) line, f of x line is the steepest. That's what they were looking for.